Here you can see a concept, the data flow variable itself, the way I'm using it inside this program. That's a paradigm. So the concept itself, it's the declarative variable. The way you use it and mix it, that's establish a paradigm. Okay, let me jump to a different namespace. The message passing, the namespace. Okay, here we have a different module. What I'm trying to present in this model, as you can see written down in the comments, it's two paradigms and three concepts. Here we have a named state, that's the threshold agent here. So I define a record. That's very basic for those of you who are accustomed to C-based language. That's just a variable, like var equals 1, for instance. When you do that, you use a concept called a record or a name state. Here we also have a clojure without the J. That's basically this function and this other function, both of them are closures. They refer to the syntactic environments, and they both can see this threshold agent, the name state, and nobody else in the world, including any other function that would be defined on this module, would be able to see this name agent besides that those functions. And we also have concurrency or independence. That's basically a concept. The way we express the concurrency, it's a paradigm. I'm trying to show here the paradigm of message passing concurrency. It's a more complex and more expressive way to express concurrency. It also leads to more problems because message passing is not deterministic, but at the same time that it's not deterministic, it's much more easily implemented. You can generate programs without locking, because locking is implicit in the message passing. So it tends to produce better programs than shared state concurrency. It's a more higher level way of program than shared state concurrency. And I also am trying to show modular programming. By that I mean this namespace, this code.messagePassing namespace, it only has one way to access it. It's not that modular programming it's about one, it's about this number, but it's about a very well defined interface to the external world, and you keep the internal components hidden, and you only interact with the outer world to those interfaces. One abstraction that I use to better grasp this concept, it's Lego blocks. They have a very well defined interface, those four little jacks that they have on top of them, those little connections. Those are the interfaces of the blocks, and they have the little connections on the bottom part also. And you can connect them in very different ways to form large structures, but each block it's very well defined, and that's what you're trying to achieve with modular programming. In this namespace, you can think of a namespace as a module, or at least you can program a namespace as a module in clojure. You can see that push it by function, it's the only, because in clojure when you define a function with this little dash, it becomes a private function. The only public function is this one, and that's the way the module will be operated by. Okay, that's the modular programming part. What else I'm trying to show here? Here I'm trying to show you how message passing works. So in the push it by function, we are sending a message to the threshold agent that's located here on line 13. We are increasing its state, that's initially 0, by a given amount, and we immediately return new. After that, we are because we have attached this behavior to this agent. Every time the agent changes its state, this little function will be called, and when the agent is not on an initial state, it will execute this function. It will just block. It will check to see if the state is larger than an arbitrary number. I've chosen 3 here. It will print boom, and else it will print save, and after that it will reset the threshold. It will always reset the threshold.